In today's video, we are going to be looking at double covalent bonding. Double covalent bonding, this is the bond that is formed by sharing of two electron pairs between two atoms in which each atom contributes two electrons. Let's take an example. Let's say we have atom A and here we have atom B. And in this case, let's say our atom A have 6 valence electrons and also atom B has 6 valence electrons. Let's put the numbers of electrons and see. Let's say we have 1, 2, 3, 4, and here we have 5 and 6. In the case of atom B, we have 1, 2, 3, 4, 5, and 6. Since we are talking about the double covalent bonding, let's donate the positive sign here. In this case, this is going to connect with this, and this is going to connect with this. This would give rise to, let's say this is the atom A, and this is our atom B in this case. So nothing will happen to the numbers of valence electrons. Our atom A is still going to have 6 and atom B is still going to have 6. But when considering the double covalent bonding, the two are going to connect at this point by sharing 2 pairs of valence electrons each. Atom A is going to join with atom B by donating 2, 2. 2 multiplied by 2 is simply going to be 4. In this case, here is going to be 1, 2, 3, 4. Remember, we have 2 here. It's going to be 1, 2. In the case of atom B, this is going to be 6 as well. 1, 2, 3, 4, and 5, 6. What happened in between this? What happened in between this? This is sharing of 2 pairs of valence electrons. So let's take an example with carbon dioxide. But before then, I need you to understand that the main group elements generally obey the octet rules. So when forming bonds, atoms are limited by the valence numbers of electrons. So let's take an example with carbon dioxide. Carbon dioxide is CO2. This simply means we have 1 carbon with 2 oxygen. Let's see how this is going to look when they share the electrons. We have 2 oxygen, this is 1, and this is 2. And we have 1 carbon. Carbon has 4 valence electrons, while oxygen has 6 valence electrons. Let's show the numbers of valence electrons here. We said in the case of oxygen, it has 6. 2 by 2 is 4. 2 by 2 is 4. Here we're going to have 1. And here we're going to have 1, which makes it 6. What about oxygen? Sorry, carbon. Carbon, which is the one at the middle, it has 4 valence electrons. In this case, this is going to be 1, 2, 3, 4. So in order for us to show the double bonding here, we can simply set this will literally connect with this. Also, this will connect with this. This is single bonding. For it to be double, you can simply show us this is going to connect with this. And this valence electron is also going to connect with this. Let's look at another structure of this. We can also set, CO2, which is carbon dioxide, 1 carbon with 2 oxygen. Valence electrons of carbon, we said, is 4. In the case of oxygen, we said is 6. So let's say this is oxygen. Let's say this is oxygen. At this point, we're going to have 2, 2, 4, 4. And this is complete. So let's try another one. Still, we're on carbon dioxide. We can choose to put it differently by writing 1 carbon, 2 oxygen, connecting them with bond. At this point, carbon shows the complete of electrons. Oxygen is 2, 2, both at the right and the left hand side. We can simply donate the other 4 to make it 6. This can be 2, 2, 2, 2. All right. And another way to show this, we can say it, we are still on carbon dioxide. We can say we have 1 carbon and we have 2 oxygen. Let's put the shell of the carbon. The oxygen, let's just donate it by maybe white. Oxygen, white. So we're still going to maintain the numbers of valence electrons. In the case of oxygen, we said it's 6. We have 2 here by 3. That is 6. 2 by 3. That is also 6. In the case of carbon, we are going to have only 4. At this point, let's try to show us what will happen when they share 2 valence electrons. This is how it's going to be from both carbons. Let's try the last one. Let's take an example with ethane. Ethane. In this case, since ethane has the prefix ENE, this simply indicates that it's alkene. And this is the molecular formula is going to be C2H4. This simply means we have carbon bonded to carbon saturated with 4 hydrogen. But in this case, since it's alkene with the prefix ENE, we're going to have at least 1 double bond in between. So C2H4, this simply means we have 2 carbon. You can set 1, 2, and we have 4 hydrogen. This is the first carbon. This is the second carbon. And we have 4 hydrogen. Let's put this one to be 1, 2, 3, and 4. One thing I need you to be familiar with is that hydrogen has positive electrons. So, and we have the carbon has 6 valence electrons. So this is simply going to be, let's use the green color to indicate the valence electrons for carbon. This is simply going to be 1, 2, 3, 4. This is, all right, what are we going to use here? Let's say blue to indicate the valence electrons for hydrogen. It has 1, 1, 1, and 1. And we said this is hydrogen, 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 hydrogen. So what are we left with? In the case of carbon here, this is 4. 2 by 2, that's 4. 2 by 2, that's 4. We are going to add 2 valence electrons in each. because carbon, remember, we are using green color to indicate, is going to be 1, 2. So this is it. If they share 2 valence electrons, this is how it's going to be. So this is it for this problem. Thank you for watching. In today's video, we are going to be looking at double covalent bonding. Double covalent bonding, this is the bond that is formed by sharing of 2 electron pairs between 2 atoms in which each atom contributes 2 electrons.